Okay, the next thing I like to do is try to build an actual cluster. So now that we've discussed some of the concepts that go behind building failover clusters, let's actually try to build one. So I'm going to do a quick demonstration here. I'm going to do all the things that you see here on the screen. I'm going to build a cluster. In order to build that cluster, I will first have to install the failover cluster feature. I'll have to set up shared storage. I will show you how to evict and add nodes. So let's go ahead and start checking it out. All right, so you're seeing my server here, and I'm going to build a cluster with these two servers, server 1 and server 2. They both already have Hyper-V installed. The first one, though, does not yet have the failover cluster feature installed. So let's do that first. So I'm going to go into my server manager, and I'm going to go under Manage, Add Roles and Features. I'm going to advance through the wizard until I get to the features list. And I'm going to turn on failover clustering. Now again, I've already done this on the other server. So obviously you need to do this on both systems, but in the interest of time, I've already done it on the other system. Okay, while that installs, the next thing I'm going to need to have is some kind of shared storage. So you might recall that in order to have a failover cluster, you either have to have what we call SAS, which is maybe an external hard drive that would be connected to both servers, or you have to have a SAN, a storage area network, or you have to have a scale-out file server, okay? In this case, what I've done is I've built an iSCSI SAN that I can connect my servers to. Okay, so I have a storage area network that's using the iSCSI standard. I'm going to connect my servers to that SAN, and then we'll be able to use disks in the SAN as our shared disks. Clusters always require shared storage. So I'm going to open up a tool called the iSCSI Initiator. This is a tool that comes with Windows Server and can connect you to an iSCSI style SAN. And it's going to ask me for the IP address of the SAN that I want to connect to. We'll see if I can get that typed in correctly. I believe it is 10.1.100.33. And it's just created the connection. Okay. Let me go out into the Disk Manager tool. And there's the 3 disks that came from the SAN, right? So those are 3 disks that are inside my storage area network. I just connected the SAN, and now I'm seeing these 3 disks. Okay, I'm going to go ahead and mark this as done. I'm going to click OK. And the next thing I'm going to do is I'm going to go into disk management. I'm just going to bring those disks online. They're not usable if they're offline. I'm additionally going to initialize them, and then I'll format those drives. All right, so all 3 are now initialized. I'll format the first one. I'll just create a partition that uses the entire space. I'm not going to bother assigning drive letters to these drives. I'm just going to create drives. They won't even have drive letters. You'll see why a little later. I'll get the second one started. Some little pop-ups will probably come up that I'll have to cancel out of. And we'll get the third one started too. Looks like maybe we're not going to get those little pop-ups that I sometimes get. Okay, well, good. So anyway, I've got the three disks and they're all partitioned. All right, so this computer is now connected to this shared storage, but what about the other server? Okay, so I'm going to go to the other server, server number 2. And I'm inside server 2, and just to prove this, let's go out to Disk Manager. You can see that at the moment, we don't see the 3 disks because this server is not yet connected to that storage area network. All right, I don't see the 3 disks here, the 3 100 gig disks. So what I'm going to do is I'm going to open up the iSCSI Initiator on this computer. I'm going to connect it into the same storage area network. I'm going to target the same IP address. I'm targeting 10.1.100.33. Connect. Done. Okay. And now you can see the 3 disks. okay? So what we have is both servers are now connected to the same group of disks. We now have our shared storage. Okay, let's go back over to server 1. And on server 1, I'm going to go back into Server Manager. We can see that the installation has completed. It's asking me to do a reboot. So we'll go ahead and make that happen, and we'll come back after the reboot. Okay, it looks like we're ready to go now. The reboot has completed. I've already logged on. I've already opened the Server Manager tool. And now I'm going to go under Tools, and I'm going to go down to the Failover Cluster console. Okay, once this console opens, what I'm going to do is I'm going to start building my cluster. Okay, so I'm going to add 2 servers, 2 nodes to this cluster. Remember, you can have up to 64 nodes in one cluster. In this case, I'm just going to do 2. So I'm going to click on Create Cluster over here on the right. And it's going to ask me which nodes are going to be cluster members. So the 2 servers I want to add are going to be SVR1, server 1, and server 2. Okay, what you see next is what we call the validation tests. I'm going to say yes to this, and while they run, I can explain what they do. So I'm going to say yes, and I'm going to say that I want to do all the tests. Let's go ahead and get that started if we can. Okay, so now it's running. So this is called the Validate Configuration Wizard. And what it does is it runs your servers through a series of tests to make sure that your cluster is going to run okay. All right, the whole idea of a cluster, of a failover cluster, is that it's supposed to be rock solid, super stable, super reliable. And so Microsoft wants to check my configuration and make sure that I meet all the prerequisites. Remember that I have to have shared disks. Remember that all the nodes in my cluster should be running the same operating system with the same update levels. And so it's doing all kinds of tests on my cluster config to make sure that when I create the cluster, it'll be as stable as possible. If I don't pass some of the tests, it'll warn me as to what it thinks I should do to make my cluster more stable. Okay? So it might give me warnings about, hey, you know, this computer is using a DHCP-based IP address, while this other computer, this other node is not DHCP-based. So therefore, the computers don't match in the way they're configured, and therefore, you really shouldn't make this cluster the way you've got it right now. Those are the kinds of warnings that this series of tests might issue at the end. All right, so we're going to have to wait another minute or 2 here as those tests complete. So I think we'll just kind of let those run, and we'll come back in just a minute. Okay, let's go ahead and start this back up. So the validation tests have now finished, and you can see a report here that was generated about what succeeded, what failed. I actually did get a failure there on my Hyper-V configuration, but when I looked at it, it was actually about fiber channel SANs, and I don't actually have a fiber channel SAN, so I'm going to safely ignore that one. But if this were a real-world scenario, you'd want to clear up any issues or warnings that it offers, okay? So whenever you see any failures or warnings, you can click on the little links to get more details. You fix any issues that might have arisen. And once you've done all that, then we can continue building the cluster. If you don't resolve all the issues that it generates in this report, then your cluster won't be supported by Microsoft. Okay, you've basically invalidated the support if you build the cluster and ignore those tests. Okay, you're supposed to go and resolve everything, make sure everything's perfect, and then build the cluster. Okay, so I'm going to click Next here, and now you can see that it's asking me for the name of the cluster. I'll call this my cluster. It's asking me to assign an IP address to the cluster. It really doesn't matter which IP address I use. It's just, as long as it's something that's not being used already on the network, I'll do address number 150. Whoops, let me try that again. I'll go on to the next step. Okay, it asks me if I want to add all the storage to the cluster. I think I'm going to say no to that for the moment. I want to show you how to manually add disks to a cluster, just so you can see what that operation looks like. So I'm going to opt out of the automatic option here and do that manually in just a minute. And we will finish the wizard. Okay, so this should go and create the cluster. Once again, we might need to take a minute or 2 here as we wait for that to run, and then we'll come back when it completes. Okay, excellent. So now it's reached the end of the progress bar, and it's telling me that the cluster has been created. Excellent. So I'll click Finish here. And I should be able to see the new cluster in the upper left-hand corner of my console. There it is. Inside that cluster, I can see the nodes. Currently, I have 2 nodes, servers 1 and server 2. I have the ability to add other nodes at a later time. So even though this is currently a 2-node cluster, I might decide to grow the cluster. So you can add another node here. You can also take a node out of the cluster. Maybe you want to shrink the cluster. You can see that you can right-click on one of the nodes, and we do what is called an eviction. Okay, that'll kick the node out of the cluster. This option here, if I right-click on the cluster, will actually delete the cluster in its entirety. For some reason, they call it destroy cluster. Somebody has a flair for the dramatic by using the word destroy instead of delete or remove. But that will basically delete your cluster. Okay, a couple other things I want to check out. Let's go down to storage. Now at this time, I don't have any disks added to the cluster. When I went through that Create Cluster Wizard, I chose not to add the disks at that time because I wanted to show you how to do it manually. So anytime you need to add storage to your cluster, we click on Add Disk, and then you choose the disks that you want to add. And there you can see the 3 100 gig disks that came from my SAN that I know that both servers are connected to. I'll add all 3. Okay, it's also possible to integrate the storage spaces feature. You might remember from another topic, we talked about storage spaces and creating things like 3-way mirrors and thin provisioning and enclosure awareness. All of those options are available to us for a cluster as well by using the storage pool feature instead. Right? I could click on Add New Storage Pool, and that will link me over to the storage spaces feature we covered in another chapter. But in my case, I'm just going with 3 simple disks. If I go down to networks, you can see here all the networks that were detected. So there's a couple different network cards in these servers. Evidently only this one provides connectivity between the 2 servers. But when you go into the properties of this network, you can just determine whether or not this network is going to be used for heartbeats. Okay, this little radio button here would say that I want this network to be used for heartbeats within the cluster. This option here would say that I allow clients to connect to the cluster through this network connection, or neither. We also have an opportunity over here to do live migration. So you might remember in the previous lesson, when we were talking about building a Hyper-V cluster, it's very common that we like to add multiple network cards. Okay, I only really have one functional network here, but it's recommended that we have multiple network cards. Then each network card can be designated for a different purpose. One can be used for live migration, another one for heartbeats, another one maybe for the clients to connect to, maybe another one for the SAN, and so on. So you can designate the roles for each of your network adapters here. Okay, the last thing I think I want to talk about is cluster shared volumes. Okay, when I go to these cluster disks, you can see an option here that says Add to Cluster Shared Volume. Okay, cluster shared volumes. So in order for both servers to be able to simultaneously access the same disk, in order for both servers in my cluster to simultaneously access the same disk, we must convert that disk into a cluster shared volume. This is an important step because otherwise, one server grabs the disk for its exclusive use and the other server can't get to it. Therefore, my first server's VMs would have to be on one disk, and my second server's VMs would have to be on a second disk, which kind of defeats the purpose of a cluster, right? The whole idea of a cluster is I want to put VMs in a shared location, and I want both servers to be able to access those VMs. So I want, server 1 to be able to run a VM, and I want server 2 to be able to run a VM when both of those VMs are stored on the same disk. In order to accomplish that, we have to convert the disk to a cluster shared volume. All right, it's very easy to do once you know that you need to do it. I'll go back into my interface here, and we just click on Add to Cluster Shared Volumes, right? And it just basically converts it to a cluster shared volume. I'll do that with 2 of my 3 disks. All right, so those are now suitable locations for storing virtual machine files like VHDs.